Morning, guys. In previous class, I have just introduced the concept of Fourier series, and also we had derived the Euler's formula, that is the Fourier series coefficients A0, An, and Bn. And this class will do some problems on Fourier series. And before starting up with the problems, first let's define even and odd functions. And you have done this in PUC. If the function f of minus x is equal to f of x, then the function is said to be even. If the function f of minus x is equal to minus f of x, then the function is said to be odd. So the same I've written it here. Let the function f of x be defined on some interval, then f of x is said to be an even function if f of minus x is equal to f of x for every x belonging to that interval. Also, you have the formula for even functions. If f of x is even, then integral f of x dx from minus L to L is equal to 2 times integral f of x dx from 0 to L. Suppose this f of x is an odd function, then this integral goes to 0. Okay. This is also the formula where you have learned in PUC from the chapter definite integrals. Okay. Okay. Provided f of x is defined and integrable on this interval. These are some examples of even function. Cos x, x square, x cube into sin x. See here, x cube is an odd function, sin x is an odd function. Product of two odd functions is an even function. And here x square is even, cos x is even. Product of two even function is also even. Okay, so this is all about even functions. And odd function. The function f of x is said to be odd if f of minus x is equal to minus f of x for every x belonging to that interval. And I said you, this integral goes to 0 for f of x is an odd function. And these are some examples for odd function. Sin x, x cube into cos x. See, x cube is an odd function. Cos x, it's an even function. Product of odd and even is an odd function. X cube is an odd function. X square into sin x. X square is even function, but sin x is odd function. And product of even and odd is odd. And I have just made a note of that. The product of two even or two odd functions is an even function. The product of an even function and an odd function is an odd function. Also, I have written those two formulas of even function and odd function here in one slot. Integral minus a to a phi of x dx is equal to twice 0 to a, integral 0 to a phi of x dx, if this function is even. It is 0 if this function is odd. See, I have written the same formulas, and instead of fx, I have written phi x, and instead of minus L to L, it is minus a to a here. Okay, so these two are the formulas you should note down. And here, in last class, I had given you 4 cases for the Fourier series expansion. In that, just we'll have a look at the 4th case. Okay, if f of x is defined over the interval minus pi comma pi, then the Fourier coefficients are given by a naught, a n, b n like this. Okay. And here, if f of x is an even function, here in this fourth case, where the function f of x is defined over the interval minus pi comma pi, here, if the function f of x is an even function, actually we are taking two cases. What if the function is even? Second case, what if the function is odd? Okay. If the function is even, see here, we'll first find what is a0. If the function f of x is even, then this integral becomes twice 0 to pi. Okay. Twice 0 to pi f of x dx, and this 1 by pi outside the integral remains as it is. Similarly, see this f of x is even, cos nx is even. Product of two even function is even. So this integral minus pi to pi of this even function will be twice 0 to pi f of x cos nx. See like this. And bn. See this f of x is even function and this is an odd function. Product of even and odd is an odd function. Okay. So integral of this odd function is 0 according to that previous formula what we went through. See this one. Yeah, this is 0 if this function is odd. So here this function is odd. So this integral goes to 0. So this is all about the first case wherein the function is an even function. If the function is an odd function, this, if it is odd, then this integral goes to 0 according to the same formula. So a0 is 0, and here this is odd and this is even. Product of odd and even is odd. So integral of odd function is 0. Okay, and here last one, if this is odd and we know that this is odd, product of two odd function is even. So integral minus pi to pi of this even function will be twice 0 to pi. See here, it is like this. So if the function is an even function, then directly without any calculation, you can write bn as 0. If f of x is an odd function, then directly you can write a0 and an 0 without any calculation. Okay, fine. So here you need to find a0 and an, and here in the second case you need to find bn, and finally you will substitute the values in the Fourier expansion, Fourier series expansion. Okay, see here, what if the function is a split function? See here, I've taken one example. F of x is equal to phi of x between the interval minus pi to 0. And f of x is defined as psi of x between the interval 0, pi. How to decide even and odd function? Here it is given. F of x is even if phi of minus x is equal to psi of x. So, replace this x by minus x here in phi of x, and that becomes equal to psi of x, then the function is said to be even. Yes, if this phi of minus x equal to minus phi of x, then it is said to be odd. So this is how you will decide whether the function is even or odd in the split functions. Okay. See, here are some examples so that it will become thorough how to decide even and odd for split functions. F of x is equal to minus x for minus pi comma 0 interval and plus x for 0 comma pi interval. See here, when you replace x by minus x, you have minus of minus x, which is equal to x. So here the function is even because phi of minus x is equal to psi of x. So the function is even. Suppose here, second example. Here if you replace x by minus x, here you are getting 1 minus 2x by pi, right? Yeah, so that is phi of minus x equal to psi of x. So here also the function is even. Suppose we'll go to third one. X minus pi by 2 for minus pi comma 0 interval and x comma pi, x plus pi by 2 for pi 0 comma pi interval. If you replace x by minus x here, then it is not equal to psi of x. Instead, it is equal to minus psi of x. Therefore, it is an odd function. And fourth one, constant function minus c for minus pi comma 0 and c for 0 comma pi. See here, I have taken phi of x as minus c and psi of x as c. If phi of x is minus c, then phi of minus x will be minus c only because there is no x term here. It is a constant. And this is minus c is equal to minus psi of x. So it's an odd function. And here, if the function is equal to modulus function, see here, mod of minus x is again equal to mod x, means f of minus x is equal to f of x. So here it's an even function. Okay, so this is all about even and odd functions, guys. Let's start up with the problem. Obtain the Fourier series for the function f of x is equal to x square over the interval minus pi comma pi, and hence deduce that there are three deductions. Okay, first we'll solve the Fourier series for the function f of x is equal to x square over the interval minus pi comma pi. See here, the function x square is an even function. Even function means, as I said you before, this bn will be 0. For this even function, bn will be 0. A0 and an you have this formula over the interval minus pi comma pi. So these are the formulas for a0 and an for the even function. See here, and that Fourier series expansion is f of x is equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx will be 0 because bn is 0 here. Therefore, there are only two terms. Third term vanishes due to this. And a0, I have written the formula for a0 and I have written what fx is here and I have integrated what x square. X cubed by 3 between the limits 0 and pi. So finally, the value for a0 is 2 pi squared by 3. I have written the formula for an over the interval minus pi comma pi. So it is 2 by pi 0 to pi f of x cos nx dx, because this minus pi to pi becomes twice 0 to pi for the even function. And I have written f of x as x square. Okay. And next here I have used the Bernoulli's general rule of integration by parts. So here, so this is the formula for Bernoulli's generalized rule of integration by parts. And here I have applied the same. See here I have taken this for differentiation and this for integration. See, the differentiation term you will choose in such a way that after some time it will vanish. See here, I will just tell you, the first term is x square. The second term is its derivative, 2x. Third term is 2x the derivative, that is 2. And the fourth term will be 0 because the derivative constant is 0. So you should choose in such a way that when you go on differentiating that, at one particular point that will vanish. So this I've taken for integration. And first term, I'll integrate this cos nx. So that is sin nx by n. And in the next term, I'll integrate this sin nx by n. That will be minus cos nx by n, and by this n will be n square. And integration of minus cos nx will be minus sin nx by n, and with n square, it will be n cube. And there will be alternating plus and minus sign. Plus, minus, plus. Between the limits 0 and pi. So here, this first term, which includes sin nx, and this last term, which includes the same, will vanish when you apply the upper limit as well as the lower limit. Okay, sin n pi is 0, sin 0 is 0. So therefore, there are no first and third terms. Only term which exists is the second term. In that second term also, when you apply this lower limit, see this, because of this x, that vanishes. So there is only one term which exists, and that is the second term of the upper limit. Okay, cos n pi by n square, and this minus into minus will be plus. Okay, 2 pi, pi and pi will get cancelled. So it is 4 cos n pi by n square. This pi and pi will get cancelled. 4 cos n pi by n square. What is cos n pi? Minus 1 power n. See, this is the formula for cos n pi. Why is the formula of cos n pi equal to minus 1 power n? Because the odd multiple of pi is minus 1, and the even multiple of pi is plus 1. So here I have written minus 1 whole power n. So when the number n is odd, then it will be minus 1. If it is even, then it will be plus 1. Okay. So here, this is all about a0 and an. Finally, I'll substitute what is a0 and an here in this Fourier series expansion, and substitute this. And what is f of x? It is x square. I substitute all here, so it looks like this. Finally, it looks like this equation 2 after substituting the value of f of x, a0 and an. And now we have done up with this Fourier series expansion of x square. And also they have asked you to deduce some 3 results. First one is pi square by 6 equal to 1 by 1 square plus 1 by 2 square plus 1 by 3 square. See, using this result, you need to deduce that. See here, if you just put x is equal to pi here, you will be getting that pi square by 6. Pi square minus pi square by 3 will be 2 pi square by 3. Then this 4, when you cross multiply, that becomes pi square by 6. And when you expand this summation, you will get 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus etc. Put x is equal to 0 for the second one. Okay. See, when you put x equal to 0, you have this minus here, there will be x square that goes to 0, and this pi square by 3 will come to left hand side, so that becomes minus pi square by 3 equal to 4 times summation n equal to 1 to infinity minus 1 power n by n square. Okay, so when you expand this summation, you will get like this. And when you take this minus outside, you cancel with this minus, you are left out with the resultant answer. And third one, see here, you have 1 by 1 square plus 1 by 3 square, 1 by, so 1 by 2 square, 1 by 4 square term not here. See here, if you add these two results, no, this 1 by plus 1 by 2 square and minus 1 by 2 square plus 1 by 4 square and minus 1 by 4 square get cancelled, and you get the RHS term. So here when you add these two, So you'll get that. But there will be 1, 2 here, so that when you cross multiply that, you will get the resultant answer. Now let's move on to second problem. Obtain the Fourier series expansion of the function f of x is equal to mod x in minus pi comma pi, and hence deduce that pi squared by 8 is equal to 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus 6. See, first we'll find the Fourier series expansion of the function mod x. See, mod x is a even function. So again, bn is 0, and again the formula for Fourier series is this. So you need to find a0 and an. Okay, this is the formula for a0 and an in the interval minus pi comma pi. So what is fx? Actually, it is fx is mod x, but in this interval 0 comma pi, it is plus x. Mod x, it is minus x for minus pi comma 0 and plus x for 0 comma pi. Okay, so here I have taken x. And once when you integrate that, you have x squared by 2, 2 and 2 will get cancelled. And when you apply the limit, you have pi square for upper limit and 0 for the lower limit. So pi and pi will get cancelled, you will get pi. Okay. And here when you substitute f of x is equal to x, and you're left with integration of x into cos nx. Use this Bernoulli's rule of integration by parts to integrate this. So when you integrate that using Bernoulli's, you get x into derivative of the integration of this is sin nx by n minus derivative of x is 1 and derivative of sin x is minus cos nx by n. With this n, that becomes n square between the limits 0 and pi. Okay. See, this sin nx for the upper limit and lower limit is 0, and this minus into minus will be plus. So it will be cos n pi for the upper limit, cos 0, that is 1 for the lower limit. So cos n pi by n square minus 1 by n square into 2 by pi. Cos n pi is minus 1 for n, and this n square here in the denominator is common. I have taken that outside, and here you are left with minus 1. So substituting the values of a0 and an in the Fourier series expansion, you have f of x is equal to mod x, and here this a0 and here this an. Expanding this summation, you have this minus 2 by 1 square cos 1x minus 2 by 3 square cos 3x. See here, when you have this n as 2, you have 1 by 2 square minus 1 whole square. Minus 1 whole square is 1. 1 minus 1 is 0. So for all even numbers of n, you have this 0. So there are no even terms here. The minus 2 by 1 square cos 1x, minus 2 by 3 square cos 3x, minus 2 by 5 square cos 5x, and so on. So this is how. And here if you put x equal to 0, you get the required answer. Okay. Obtain the Fourier series of the function f of x is equal to x over the interval minus pi comma pi, and hence deduce that. See here, x is a odd function. So a0 and an here are 0. We'll find what bn is. And before that, your Fourier series expansion for f of x looks like this. As a0 and an are equal to 0, first and second term vanishes and only the third term exists. Okay. So where bn is given by this formula. Okay. So I've written what fx is, and I have integrated by Bernoulli's formula. Okay. Same as the previous problem. We'll get like this. And using that in Fourier series expansion, you have x is equal to summation n equal to 1 to infinity bn sin nx. Okay, so this is all about the expansion. For reduction, when you substitute x is equal to pi by 2, you have this pi by 4. And when you expand this, you have this 1 minus 1 by 3 plus 1 by 5 minus 1, and so on. Moving on to the next problem, obtain Fourier series expansion for f of x is equal to minus k, here it is plus k. So it's an odd function. Okay. See this, consider this as phi x. Yeah, I've written it here. Phi of x, psi of x. And here where phi of x is equal to minus k and psi of x is equal to k. But what is phi of minus x? Phi of minus x is equal to minus k and not equal to the psi of x. It is equal to minus psi of x. Therefore, that becomes an odd function. So, therefore, a0 and an here are 0 and bn, only bn exists, and the formula for bn is this. And 0 to pi, f of x is k. Okay, you can take that constant k outside and integrate the sin nx. Integration of sin nx is cos nx by n with a minus sign between the limits 0 and pi. So after applying upper limit and lower limit, you will get like this. And after substituting the value of bn here in the expansion, you have this. Okay. So this is all about fourth problem. Next one, obtain the Fourier series for f of x is equal to 1 plus 2x by pi between the interval minus pi and 0, 1 minus 2x by pi between the limits 0 and pi. Here, f of x is an even function because phi of minus x is equal to psi of x. Okay, therefore it is an even function. Even function is a0 an exists and bn equal to 0. So we'll calculate what a0 and an are. See, when you use the formula for a0 and integrate this 1, you have x. When you integrate this x, you have x squared by 2. This 2 and 2 will get cancelled and you are left with pi here. So when you apply the limit, upper limit, which is 0, lower limit is also 0. So the final answer for a0 is 0. So here in this problem only an existed. Okay, let's see what an is. 2 by pi, so this is the formula f of x cos nx dx. F of x here is 1 minus 2x by pi for the limit 0 to pi. So when you integrate this using Bernoulli's rule for integration by parts, you have taken this for differentiation and this for integration, because at some particular point this will vanish. Okay, and therefore it is 1 minus 2x by pi into integration of cos nx, that is this, minus derivative of this into integration of this between the limits 0 and pi. So when you apply these limits, you'll get like this. And after substituting this an here in this Fourier series, you have f of x is equal to summation n equal to 1 to infinity an and cos nx. Okay, so this is all about today's class, guys. Let's do some more problems on Fourier series in the upcoming classes. Thank you.